All right, we talked about what a precipitation reaction is. That's when we mix two aqueous solutions together, and a reaction occurs in which they make a solid and a solid falls out of solution. That solid is called the precipitate. Not everything is soluble, meaning it dissolves in water. Some things are insoluble, which means they form a precipitate. So we're going to look at the rules that this class will use for determining if something is aqueous, meaning it will stay in solution, or it will become a precipitate and become a solid when it's mixed together. And you'll find if you look at different sources, these rules will vary a little from source to source, but these ones here, and you should have this in your packet at home, so if you can't read these charts, just pay attention to what boxes I'm pointing at. These rules tell us that if something meets these criteria, they're soluble unless they also meet these other criteria, and they're an exception to this solubility, so they would be solids. So if they fit in this rule, then they're soluble, which means they're aqueous. If they fall in this box, they're solids, which means they're a precipitate. If they fall in these rules, then they're a solid and they're a precipitate. If they meet one of the exceptions to these rules, then they're aqueous and they would stay in solution. So for example here, soluble compounds contain group 1 metal cations, and remember group 1 is the first group in our periodic table, and ammonium ion, which is NH4+. Halide ions tend to be soluble. Those are the halogens that have lost or gained an electron, so now they have a negative charge. And the acetates, bicarbonates, nitrates, chloride ions tend to be soluble, as well as sulfate. So to be able to do this, you really need to be up on your naming, and you need to know what your polyatomic ion names are, because a lot of these contain polyatomic ions. All right. So if we look at this first compound here, this would be sodium carbonate. And so what we want to do is see if there's any rules here that apply to sodium or carbonate. So if we look at this first rule, it says group 1 metal cations, and it lists sodium +1 as a group 1 metal cation. They tend to be soluble. And then what we do is see if there's any exceptions. And so there's exceptions for halides and sulfides, but there's no exception for carbonate. So we would, and here it says carbonates tend to be insoluble. But if we look at the exception to these rules, components of carbonates with type 1 metals tend to be aqueous. So it fits in both of these two boxes, so we would expect this to be aqueous or AQ for this compound. If we look at the next compound, we have calcium chloride. And so we want to see if there's any rules about chloride or calcium over here. And if we look down here, we see that halide ions, including chloride, bromide, and iodide, tend to be soluble or aqueous. And then we look for exceptions, and halides, if they have silver +1 or lead +2, are exceptions. So there's no exception for calcium. So we'd also expect this to be aqueous or stay in solution. If we move to the next one, we have silver chloride. So our rules tell us that halides tend to be soluble, chloride is included there, but the exceptions are halides with silver +1 tend to be insoluble, so this would be a solid. As we keep moving along, we have here barium sulfate. So we want to look for rules about barium or sulfate. So here it says sulfate, SO4 2-, tend to be soluble. Sulfates with barium 2+ are an exception, so we'd expect that to be a solid. So although sulfates tend to be soluble, those with barium are not. When we come to our next one, we have ammonium sulfide. So we look for rules on ammonium or sulfide. Here it says ammonium ions tend to be soluble. There's no exceptions for sulfide. There's exceptions for sulfates. So we'd expect this to be aqueous as well. Moving down, here we have copper 2 hydroxide. We're going to look for rules about hydroxides. Here it says hydroxides tend to be insoluble, and there's only exceptions for group 1 metals and barium 2+, which copper is not one of those, so we expect that to be solid. Move on, we have barium hydroxide. We said hydroxides tend to be solids, but the exception is with barium 2+, so we expect this to be aqueous. Moving further, we have calcium phosphate, so we're going to look for rules about phosphates or calcium. Where are our phosphates? Our phosphates are here. They tend to be insoluble. Exceptions are for group 1 metal. Calcium is in group 2, so we'd expect this to be solid. Moving on further, we have barium nitrate, so we're going to look for, or lead nitrate, sorry. Look for rules about nitrates, and we see that nitrates tend to be soluble, so we're going to see if there's any exceptions. There's no exceptions over here for nitrates, so we'd expect this to be aqueous. And our final one is our lead 2 chloride. So this tells us chlorides tend to be soluble, but exceptions for halides such as chloride are if they're with lead 2+. So that would be an exception there, so that would be a solid. So you should be able to look at one of these compounds and using these solubility rules determine if it's going to be a precipitate or stay aqueous. If it falls into one of these two boxes, it tends to be soluble. If it falls in one of these two boxes, it tends to be insoluble or be solid.